Hello everyone and welcome to a tutorial where I will be explaining the derivatives of sine, cos and tan. Now we won't be going through anything more complex than just directly deriving functions in the form of sine ax, cos ax or tan ax where a is just a multiplicative constant, i.e. a is just a number. So things like deriving sine 3x. Now pretty much it's quite simple. There's just some basic rules you have to follow. Now, the derivative of sine ax actually comes out to a cos ax. That's just a rule. Proofs exist for all three of these. I'm not going to go into it in this video, but proofs definitely do exist. Um, the derivative of cos, alternatively, is very similar, but it's slightly different. The derivative of cos ax is actually negative a sine ax. So sine and cos, you got to be careful because when you're deriving sine, you end up with positive cos, whereas when you're deriving cos, you end up with negative sine. So that's something to be very careful with. Next, the derivative of tan ax ends up being a sec squared ax. Now, if you're unfamiliar with sec squared, don't worry. I'll explain that towards the end of the video. For now, we're just going to do a couple problems with sine and cos, and then I'll explain tan, because sec squared might be new notation you haven't seen previously. Now, pretty much what we're going to be doing is we are going to be having a go at some problems. So, let's have a look. What do we got? All right, so first question, we're going to look at if we have a function such that y equals 3 sine x what would dy dx equal is the question. Well, we just jump straight to our formula. In this case, we know that a is 1, i.e. there is no multiplicative. The multiplicative constant in front of the x is 1. So the derivative of sine ax is a cos ax, where a in this case is 1. So we ignore the 3, we just leave the 3, and we're just going to jump straight to cos x. And by that, we can see that the derivative of sine x is cos x. So the derivative of 3 sine x is going to be 3 cos x. Now, let's give another one a go. Let's give one that's in the form of cos a go. Let's try deriving y equals 2 cos 4x. Let's give that a go. So 2 cos 4x is what we're trying to differentiate. And to find dy dx, once again, we just apply the formulas that were given above. And we see that in this case, a is actually 4. When we're looking at the formula, a is 4. So what we're going to do is we're going to put a negative a on the front. So negative 4. And then we're going to times that by the 2 that was on the front, because we don't do anything about the 2, we just leave it there. But we're actually going to switch cos and sine. So we're going to end up with negative 4 times 2, and we're going to switch to the sine function. We're going to switch to sine. So we're going to get sine 4x. And of course, that can be simplified to give us negative 8 sine of 4x. Alrighty, so as you can see, when we started with a positive cos, what we want to do is derive that, and we end up with a negative sine as shown through here. Now, another one that we should probably give a go is one where you got to be very careful here, because what can happen is that when you have negatives on the front, on the outside of the equation as opposed to the inside, you got to be really careful of the way you flip it if you're going from cos to sine, i.e. deriving cos, because it's easy to make sign errors, that is screwing up the negatives. But if you take it slow, you shouldn't have any problems. So we're going to give deriving negative 2 cos x a go. So we'll just jump up here, go up here. We'll go d on dx, directly finding the derivative of negative 2 cos x. Alrighty, so we need to think what is that going to equal? Well, for starters, a is 1, so we don't need to worry about timesing anything on the outside. But remember, when we go from cos, when we derive cos, sorry, we're going to end up with negative sine, and we have a negative on the outside already. So we're actually going to get a negative. We'll write negative 2 times negative 1 sine x. Sorry, I'm out of space here. We're just jumping actually onto the line below. We'll say that's equivalent to negative 2 times negative 1, and then it is sine of x. So we actually end up with positive 2 sine x. So that's where you got to be really careful because we actually are deriving cos x, we end up with negative sine, but we had a negative on the front. So that means the negatives are going to cancel out to give a positive number. So we end up that the derivative of negative 2 cos x is just 2 sine x. Now, that's where you got to be really careful and not just jump to the idea that if you see cos, the answer must always be negative sine. You got to be careful about the constant out the front if that's positive or negative. Now, we're going to move on and have a look at tan now. Now, you might not have seen this notation previously, the idea of sec squared. I'll just define sec first. The function sec, switch to another color. Sec actually means, sec of x, for instance, actually means 1 on cos x. It's not the same as writing cos neg 1 of x, i.e. inverse cos. It's actually 1 over cos. It's very different. Don't get those two mixed up. It's very different. So sec of x is 1 over cos x. And sec squared of x, or for that matter, any trigonometric function squared, when you see it like that, just means sec of x all squared, like that. So therefore, it would make sense that sec squared x is equal to 1 over cos squared x. And this becomes important when we try to derive the tan function. Now, let's get back to blue, and we're going to now have a go at deriving the tan function. So we're going to have a go at taking the derivative of tan 3x. So it's just d on dx of tan 3x. Right, so d on dx of tan 3x. As you can see, a in this case would be 3. And what we're going to be doing is we're going to just jump straight to the answer because that's all we need to do. It's a one-step problem, but we're going to write it in multiple forms. So we're going to end up with 3 sec squared of 3x. But you could stop there. However, if the question wanted you to, and or maybe you're trying to evaluate the value of the derivative at a certain point, it would be wise probably to write it in a form like this because it's a lot easier. We know how to find the exact values of cos. We're given our special angles such as pi 6, pi 4, or pi 3. And for that matter, the derivative of tan 3x not only can be written as 3 sec squared 3x, the derivative of tan 3x can also be written as 3 over cos squared 3x. So if you had to find the derivative at a certain point, i.e. plug in a number, for x, you could find that a lot easier because we're using cos as opposed to sec. Anyway, that's essentially it for just finding the derivatives of sine, cos, and tan, given that they're in the form that was described over here. So, as you can see, it's really not that difficult, but what you do want to be careful of is whenever you have any negative signs involved, just be very careful not to accidentally sign flip because obviously you'd get it wrong and it'd be annoying to get something wrong just because you got the minus sign either there or you accidentally omitted it. And yeah, that's essentially it. And with tan, tan's not too difficult either. It's just this sec squared might look a bit strange if you hadn't seen it previously, but now you know it's just 1 over cos squared x. So that's pretty much it for this video, guys. Thank you very much for watching, and I'll see you all next time.